Hello, my dear boys. All of you are welcome to my online class. This is a special class for class 9 and class 10 English version. Hope all of you are well by the grace of our Almighty. Today we will discuss on web and sound, and the topics from this chapter is creative question solution. Today we will try to do a creative question solution. Okay, so let's see our today's creative question. So our creative question is: two sound waves have frequency of 340 Hz and 400 Hz, and difference of their wavelength is 0.165 meter in medium A. Again, the velocity of sound in medium B is 400 meter per second. The question A is: what is uh, intensity of sound? What is intensity of sound? The question B is: show relation between frequency and time period. Okay, and question number C is: calculate the velocity of sound in medium A. And question number D is: if the difference of the wavelength is 0.1 meter, then can one wave is in B medium cover 160 meter in 100 vibration? Show mathematically. Repeat it again. Two sound waves have frequency of 340 Hz and 400 Hz, and difference of their wavelength is 0.165 meter in medium A. Again, the velocity of sound in medium B is 400 meter per second. Okay, so the question A is: what is intensity of sound? Question B: show relation between frequency and time period. Question C: calculate the velocity of sound in medium A. And the last one, question D, is: if the difference of the wavelength is 0.1 meter, then can one wave in B medium cover 160 meter in 100 vibration? Show mathematically. So this is a full set creative question. Now I will discuss this solution of this question part by part. Okay, so the answer for question number A. What is intensity? So write down: measure intensity is a measure of how loudly a musical sound can be heard. Okay, and therefore the amount of sound energy sound energy that flows per second per unit area is called intensity. Okay, so intensity is a measure of how loudly a musical sound can be heard. Therefore, the amount of sound energy that flows per second per unit area is called intensity. So this is the answer for question A. Now we will discuss for the for the answer for question number B. Here we need to show the relation between time period and frequency. First of all, we need to write down the definition of frequency. The definition of frequency is the number of complete vibration of a vibrating particle in 1 second is called frequency of a wave. Okay, the frequency of a wave is denoted by A, and the definition of time period is the time of a complete vibration. The time of a complete vibration is called the time period. So here time period T is denoted by capital T. So we can write if the time period is T, according to the definition of time period, at T time we get one complete vibration, one number of T time, number of at T time, number of vibration equal to 1. So at 1 second number of vibration equal to 1 by T. Okay, so according to the definition of frequency, I am repeating the definition of frequency, that is the total number of complete vibration in 1 second is called the frequency. So here you can see that at 1 second the number of vibration is 1 by T. So according to the definition we can write F equal to 1 by T. So this is our relation between frequency and time period. So this is our relation between frequency and time period. To complete this answer, you need to write the definition of frequency, definition of time period, and if you wish you can complete this answer by using this unitary method. Okay, so you will get a full number. So this is our hints for question number B. Okay, answer for question number B. Okay, now the question number C. Question number C says that calculate the velocity of sound. Calculate the velocity of sound in medium A. For calculating the math, we have given two frequency here. The frequency the frequency number 1 is A, so F is given, and that 340 Hz, and AB is given that 400 Hz. Okay, and here given a difference between wavelength, but does not mention the difference watt from watt. Okay, which wavelength from which wavelength. And here we need to calculate this, or we need to write this difference by using these two frequency. We know that the relation between frequency and wavelength is V equal to F lambda. So if V is common, or in a medium V will be, for one medium V will be always constant. So the relation between frequency and wavelength is inversely proportional. F is proportional to or we can write lambda is proportional to 1 by F. Lambda wavelength is inversely proportional to the frequency. We know that. Okay. So we can say that if the frequency is greater, then the medium of that frequency will be smaller. Okay, if the frequency is greater, then for that frequency the wavelength will be smaller, and if the frequency is smaller, for that frequency wavelength will be smaller. Okay, so according to our this information, we can write according to this thing, we can write lambda here 400 is greater, so frequency of wave B will be smaller. So lambda A minus lambda B equal to 0.165. Okay, or we can write here lambda equal to V by F, using this relation lambda equal to V by F. We can write V here. V is common because the medium is 1. Okay, so V by, we can write Fa minus V by Fv equal to 0.165. V is our velocity of sound in medium A. So we need to determine V. So we can write 1 by Fa minus 1 by Fb equal to 0.165. Okay. Putting the value of Fa and Fb, we can write, or V equal to Fb minus Fa equal to 0.165 into Fa into Fb. Okay, so or V equal to 0.165 into Fa into Fb by Fb minus Fa. So putting the value of Fa and Fb and calculating, we will get Fa is 340 Hertz and Fb is 400 Hertz. Here 400 minus 340 by calculating, therefore V is 374 meter per second. So the velocity of sound in medium A is 374 meter per second. So this is our answer for question number C. Okay, here V is 374 meter per second. Now we will discuss about the answer for question number D. Okay. For question number D, we will use the same frequency. But here we have a different condition. Here the difference between wavelength is 0.1, and we need to discuss that for 100 vibration, it will cover 160 meter path or not. So for this question we need to determine the distance traveling by the sound wave, and we can use a formula, and that is S equal to n lambda. Here n is the number of vibration and lambda is the frequency of the mentioned sound wave. Okay, here according to the question, we see that we need to determine this distance for medium B. So here we can write n into lambda B. So first of all we need to determine lambda B, and for lambda B we need to determine the velocity of sound of medium B. Okay, so according to our stream, S is according to our stream, we can write here the difference between the two wavelengths is 0.1, and again using the condition of this wavelength, this frequency, we can write the difference between the wavelength as lambda A minus lambda B equal to 0.1. Again V by FA minus V by FB equal to 0.1. Okay, or 1 by FA minus 1 by FB equal to 0.1, and therefore V equal to 0.1 into FA into FB divided by FB minus FA. Okay, so we can write V equal to 0.1 into for FA 340 Hertz and 400 Hertz, and therefore 400 minus 340. So calculating these values, we can get the velocity of this sound in medium B is 226.67 meter per second. Okay, so this is the velocity of sound in medium B. So here we get the velocity of sound in medium B. Then using this velocity of sound we can calculate the wavelength of medium B. We know that V equal to FB lambda B for B medium. Okay, the two wave for wave A, we can write for B equal to FA lambda A. So lambda A equal to B by FA, and our V is 226.67 divided by FA is 340. So lambda is 0.6667 meter. Okay, and lambda B is V divided by FB equal to 226.66 divided by 400, and answer is 0.5667 meter. Okay, so we get the wavelength of these two wave now we can easily determine the distance covered by these two sound wave. Okay, here the total number of vibration is given, and that is n equal to 100. So for wave A, this information is very important. Lambda equal to 0.6667 meter, and lambda B is 0.5667 meter. So for wave A is A equal to n lambda A. Here n is 100 and lambda is 0.6667 meter. So we can write 66.67 meter. And again for wave B is SB, distance covered by wave B is denoted by SB, and SB is n into lambda B. So 100 into 0.56667, and calculating we get 56.67 meter. So for both wave A and wave B, we see that no one wave is covered a distance 160 meter. Okay, so we can write no one. So we can write no one wave can cover 160 meter in medium B. Okay, so this is our solution for question number D, and the discussion is very important. Discussion part is very important for question number D. Okay, so this is all for today. In our next class, we will discuss another creative question on this chapter. Okay, so until then, good night.